Hey there, we're going to look at 6.2 today on solving linear systems by substitution. And I just want to give you a heads up first before I start this lesson that I broke my stylus yesterday. And so if the writing looks a little less than optimal, that's what happened. So let's go ahead and get into this lesson and see what we got. So our objective today is that you'll be able to solve systems of linear equations using substitution. And again, this falls under our standard of AREI 0.6, and specifically in that standard, one of the subsections specifically says that substitution is a standard. Okay, so what I want you to first think about before we even get to an example, I want you to look at this. 4/4 is equal to $1, right? Now, if you got this in your house, go grab 4/4, go grab $1, right? And if you were to go to the grocery store, right, you could spend either one and pay for something that costs $1, right? The cashier would take the 4/4, they would take the $1, right? If you go to a vending machine will take 4/4. Vending machines, most times when they're working, will take the dollar bill, right? So they spend the same, right? Now they feel different in our hands because one's a dollar bill and the other's 4/4 made of metal, right? So they're made of different materials, but they are worth the same thing. And that's what we're going to get at with this section today, is we want to understand that I can replace one item for another when they're equal to each other. And that is the substitution property of equality. Now, so let's look at example 1. We have y is equal to 3x minus 1 and y is equal to 5. Now, we can go to our graph and see where this solution will be, but we want to use our second method here, substitution. And so when we use substitution, what we're wanting to do is we want to have one of our variables set equal to everything else. So I either want it to say y equals and then everything else behind it, or I want it to say x equals and everything else behind it. Because what we're going to do, and we'll look at this in this first example very easily, is the second line has y equals 5. And so everywhere I see y in the other equation, right here, I'm going to take the other part, right? So if y is equal to 5, I can substitute y with 5. And so what I'm going to write for my next line is that 5 is equal to 3x minus 1, right? And now I can solve for the x. And so doing that, I'm going to add 1 to both sides. And doing that, we get that 6 is equal to 3x. And then we'll divide both sides by the 3 to get the x by itself. And again, I apologize for the pen. Okay. And so when I divide both sides by the 3, I get that 2 is equal to our x. And so when I'm thinking about this ordered pair here, the first part is 2. And so now we need to figure out what the y is. Now in this problem, we're already told what y is. We were told right here in our orange highlight that y was equal to what? 5. And so that's the solution. Now, could I go to my graphing calculator? Could I go to Desmos or some other graphing tool and graph these two lines up and see where they intersect? Absolutely. And we're going to see that that intersection will happen at 2, 5. And so just doing a quick sketch here, just to remind ourselves. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. And so graphing this up, first line y equals 3x minus 1. So I'm going to start with my y-intercept at -1. I'm going to go up 3, so 1, 2, 3, right 1. So my dot will be right there. And again, like I said, apologize for the issues here, trying to get it to work. Okay, so my y-intercept was down here. And then up 3, right 1. And if I go up 3, right 1 again, I end up here. And my other line is y equals 5. And so that's just at 5, I'm going to have a horizontal line going across like so. Draw a red line in. And we see that that order pair is at 2, 5. Okay? So that's it there. Now, we're not going to deal with a horizontal line every time, and that's what we're going to look at in example 2 and example 3 today. So in example 2, we've got y equals 3x minus 1. Well, we just use that line. But now we're going to do it with y equals negative 2x plus 4. And so when I have two equations, and again, only one has to be set equal to y, but if I have both, that's fine. And I could take either one, but I'm going to take the bottom one, and it says that y is equal to negative 2x plus 4. And so we're going to take all of this and plug it into y in the other equation. And so what I'm going to write is this. So here's the y. I'm replacing with everything I've circled in blue. So negative 2x plus 4. And now I've got the other side of the equation, 3x minus 1. Now here's one thing I want you to pay attention to, and this is a common mistake. When we substitute, do I keep the other part? Think about our 4 quarters and dollars, right? If you want to trade somebody 4 quarters for a dollar bill, do you get to keep both? No. You've got to replace one for the other. And so the y goes away, and what we're substituting in this case the negative 2x plus 4, goes in its place. And now we'll solve this out. Okay? And so I'm going to add 2x to both sides, and I get that 4 is equal to 5x minus 1. I'm going to add the 1 to both sides. So 5 is equal to 5x. And dividing both sides by the 5, we get that x is equal to 1. And so the first part of my order pair is that the x coordinate is 1. But I'm not done here, because I only have the x. I got to find the y. So now I'm going to take this piece of information and plug it back into one of my originals. I can plug it into the first equation, or I can plug it into the second equation. And I'm going to plug it into the second in this case. And so what I'm going to get is y equals negative 2. I'm substituting the x for 1, right? So I'm going to substitute the 1 in, and then plus 4 out back. And we'll simplify this so we get the y by itself. So that's going to give me y is equal to negative 2 plus 4. So y is equal to 2. And so that becomes the y coordinate of my intersection. So where would these two lines cross? If we graph them on the coordinate plane, they would cross at the order pair 1, 2. Okay? So again, it's as simple as that. So if we want to define the steps here, well, let's do that real quick. So what is step 1, right? Step 1, okay, and I'm going to type this out so that way it's nice and legible. So those steps are this. Number 1, solve one of the equations for one of the variables. Now, in example 1 and example 2, the equation was already solved for us, and so we don't have to do anything new here. We're going to look at example 3 in a moment and see how we solve for one of the variables in the equation. Step 2, solve for what you found, or substitute what you found into the other equation for the variable. And so as you see, we took what we found here, and substituted it in for the variable there, right? It said y equals that whole part that we circled in blue, and in the other equation, we substituted it in here, okay? Step 3, solve that equation for the remaining variable. And so that's where we took this. The only variable left in this problem was x, so I want to get it down to x equals something. It should be a number, okay? We'll talk about special cases on our next lesson on the next Monday, okay? Step 4, substitute what you found into either equation and solve for the remaining variable. So I solved this for x. I'm going to take it and plug it into either equation for the x, and I'm now going to solve for the other variable, which in this case would be the y. And finally, our last step, solve for that remaining variable and then we're going to write our answer as one ordered pair. We have an x, and we have a y, and we're going to write that in the appropriate order here to get our final answer. Okay, so let's look at example 3 and deal with step 1 in this problem, and also deal with problems that don't come out perfectly. And I know that's y'all are going to be like, oh my god, there's going to be decimals and fractions in this, and yes, that is what's going to happen here. We are going to get a decimal or a fraction in this answer. But guess what? That's life. Everything is not all nice numbers, right? Go to the grocery store. It's not $4 for this and $6 for that. It's $3.88 for this and $4.99 for that. You got to deal with decimals. You got to deal with fractions. If you're measuring and baking, you got to deal with fractions, y'all. So let's get to it. So example 3, 2x plus 4y is equal to 0, and x minus 2y is equal to 2. Now, let me give you a suggestion here. If you have an equation where you have a variable that does not have a coefficient, that's the number in front of the variable. So again, if you have an equation where you have a variable that does not have a coefficient, which means its coefficient is 1, that's the one you should solve for. Now, we can solve for any of them. I could choose to solve the first equation for either the x or the y. I can choose to solve the second equation for either the x or the y. But in this case, I'm going to look at the second equation and solve this for the variable that does not have a number in front of it. Okay, and so I'm going to solve the second equation for x. So how do I get that x by itself first? That's step 1. And wow, we just jumped screens there. Let's go back here. So x minus 2y equals 2. How do I get this x by itself? I've got to add the 2y to both sides. And I know what some of you are about to do. You're going to be like, this is 4y. No, it is not 4y. This is 2y plus 2. Because these are not like terms and they do not add together. Again, these are not like terms, they do not add together. So x is equal to 2y plus 2. Do not combine this into one nice little thing, because it's not what happens. Okay, so now I've got this set equal to x. Okay, so I'm going to take this, and I've got to plug this into the other equation. I solved the second equation for x, so this must go into the first equation for x. And so what I'm going to get is this. We have the 2 that was in front of the x. And then I'm going to put this part in blue. I'm going to take all of this and put it inside a parenthesis. And so I'm going to get 2y plus 2 right there. And then I'm going to copy the rest of that first line. So coming back to my green, I'm going to copy the rest of what I had here. Plus the 4y equals 0. Okay? Let's see what happens next. So now I've got, distributing this, 4y plus 4 plus 4y is equal to 0. And I know what some of you are about to say now, that these 4y's cancel. No, they're on the same side of the equal sign. So we combine like terms with what it tells us to do. 4y plus 4y is 8y plus the 4 is equal to 0. Keep solving here. So now we're going to minus the 4 from both sides and get that 8y is equal to negative 4. And dividing both sides by the 8. And Lord above, help me if any of you tell me that this is negative 2. Because it's not. The 8 is in the denominator. This is negative 1/2. Because 4 divides by 4 to get 1, and 8 divides by 4 to get 2. Okay? So I have now found the y. And so I know in my ordered pair that my y value will be negative 1/2. But I still got to find the x. And so that's where we got to come back and take this and plug it into one of the originals. I can plug it into either one. Whichever one is going to be easier to work with. And so I think the second equation will be the easier of the two to work with here. Again, you could choose the first if you want to. You'll get the same answer if you do everything correctly. Okay? But again, choose wisely. So x minus the 2, I'm substituting in the negative 1/2 from here for the y, and finishing out writing the second equation, it was equal to 2. And so what is negative 2 times negative 1/2? That is positive 1. And so I get that x plus 1 is equal to 2. And then I'm going to subtract 1 from both sides. So minus the 1, minus the 1. And I get that x is equal to 1. And so my x value is 1. And so the point of intersection here is at 1 and negative 1/2. And so this would be just below the x-axis. And again, if we graph this on the coordinate plane, we're going to see that that's where this is going to cross. And that's what I want y'all to understand with this. This is not difficult. But for some reason, students want to make substitution something crazy and just convoluted. It's not. Is it a few steps to do? Yes. I mean, look at the screen. There are multiple lines here that you have to do. But understand, these are all things you know how to do. You know how to substitute in for a number. Now you're substituting in with an expression, like 2y plus 2 in this problem. You know how to solve for x. You know how to solve for y. You know these things. Just do all the steps. Again, I know it looks long. It's not long. And as you get good at this, you can do these very quickly. Okay? I mean, it took me probably about 4 minutes to explain this problem. But if I'm not explaining it, and you just go through the process, it doesn't take long to solve this, y'all. So that's it for this video today. Again, the word of the day, if you didn't catch it in the first video, is substitution. Again, the word of the day is substitution. And so make sure you get that into your Google form to get checked in for today. And make sure you get your assignment submitted. And don't forget that you do have a quiz on 6.1 that was on quizzes. I don't care which order you get these done in. I mean, as long as it gets turned in. If you want to do this first and do that second, I don't care. But that quiz is out there as well. And both this assignment for 6.2 and that quiz are both going in as grades for today. So I hope you'll have a great day. Have a great weekend. And I will catch y'all next week if I need to update y'all on Wave Week stuff. But otherwise, my next video will probably be about a week from now. So y'all have a great day.